Okay, so last time I asked you to do those questions on page 29, right? And all you needed to do was ask yourself, really doesn't matter, ask yourself, is the question acceptable or not? And if not, then you needed to rewrite it as necessary to make it work, right? So, I'm going to just ask for some volunteers. So the first question, is the median weight of Year 9 students in New Zealand larger than the median weight of Year 7 students in New Zealand? What do y'all got? What do y'all think? Yes or no? Yes, that one's complete. It tells you what you're measuring. It tells you who you're using as your population, right? And so the question is very complete. Now, you could have also put a unit on there if you wanted to, but again, that's not completely necessary, but it would certainly look good when it's being marked if you do, right? Okay? Number 2, is there a difference in the time spent on homework for boys and girls? Good or bad? Yeah, that one's not going to cut it. What's wrong with it? It's a good question and an interesting one to study, isn't it? But what's wrong with it? Sure, we don't have any units. We don't know how we're going to measure it, what we're going to measure it in, and we have no specific population. So how did you fix that one? How did you fix it? What could you add? You didn't fix it, okay. What could you add? We just need a population, right? So we could say, is there a difference in the median time, right? We need some kind of statistical measurement in there. Is there a difference in the median time spent on homework for boys and girls? What? In Year 12 not Queen Margaret, but yeah. In Wellington schools, in all Wellington schools or something, right? So make sure that you're getting that statistical term. They have to say median or some kind of measure, right? Just some kind of measure. Okay. Is the Year 12 male's head circumference bigger than the Year 12 female's head circumference? What are you actually measuring? Is it a median head circumference? Also, Year 12, does that mean every Year 12 student in the whole planet? So you might need to be a little more specific to your population because you're not going to be able to measure everybody in the world, right? So you're not even going to be able to measure everybody at your school or in special things. Okay, how does that look? Do girls have, I'm dropping way down here. Do girls have more apps on their phones than boys? It's a great study question, right? It could be very interesting to see, but is it properly written? No. Okay? Anybody want to take a stab at rewriting it? Anybody? You're not being brave? Come on, somebody know? All right. So, is the median number of apps on the phones of girls at Wellington High higher than the median number of apps on the boys' phones at Wellington High? Something like that. I mean, that's just me talking. But you see what I'm saying? It's very simple, the idea. Just have a few basic things you want to do. And also there's a phrase, too, that they like for you to use. Instead of, is there, what is it? I wonder if. Okay? I wonder if. Excellent. So today what we're going to do is we're just going to continue on in the book, looking at, starting on page 33 there. We're going to talk a little bit about sampling methods. First of all, do you think it's possible to use the entire population in most cases as for your statistical experiment? No way. Right? Now, if your population is very small, then, yeah, you could use everybody. But what's wrong with using a very small population? Yeah, it's going to be difficult to get good data, right? For example, if I was going to ask about clothes worn to school from the students in this class, I wouldn't get a lot of good information, right? Do you think that the clothes you wear are indicative of the clothes of all students in New Zealand? No, right? So you've got to be careful when you're choosing your population. And because we can't choose the entire population of New Zealand, what we're going to do is we're going to pick random samples or a representation of the populations. So our sampling methods, so look at what we need to include. We need to include where the data is from. Did you ask only people who go to Queen Margaret? Did you ask people on the street, in Wellington? But even if you ask people in the street, you should still be specific about where, okay? So where did the sample come from? What kind of sample? In other words, how did I select those people? Did I just walk up to somebody and say, hey, right? Did I stand on the street? Was my experiment how many people who walked by wearing blue, right? How did I sample them? How did I pick those people out? And if so, why did I choose the street that I chose, right? And do you think the results would be different on a different street? So you can pick what kind of sample and how. And how many you're sampling. If my sample is 3 people out of all the people in Wellington, how good do you think my results are going to be?
Bad.
Pretty bad, right? But do I want to pick 200,000 people in New Zealand? Yeah. I'd like to, but how likely is it that you're between now and then y'all are going to talk to 200,000 people? Not, okay? So, for example, your statement says, I will be using the information in the data set provided by blank. Now, we're going to just go to NZ Grapher and pull existing data. But there's going to be a title and some information from that you need to gather. You need to make sure you mentioned where your data comes from, okay? And I will take a random sample. Why do you think it might be important to take a random sample? Yes? Yeah, to help prevent bias. And remember we had that glossary of terms at the very beginning that you hopefully all filled out. I'm sure you did. Bias means what? That not everyone has a fair chance of being selected. Yeah, but bias means that's a random sample, but bias means some preconceived notions and ideas, right? Am I going to ask you guys about, I don't know, give me something that you're really, really interested in. I know you're teenagers, but you still have something. Come on. Books, okay. All right. If I was going to ask the people about books, what a face. If I was going to ask people about books, right, would you ask your reading club? Would that be a good sample? No, it wouldn't be indicative of what's going on, right? You need to include a sample of everyone, yeah? If I was going to ask how many students in the New Zealand system have laptops, would y'all be a good sample? No. Because you got to have one, right? Okay? So you've got to be very specific about it. A random sample literally means that every person or thing in the population has an equal chance of being selected. Right? So anybody in the entire population has an equal chance of being selected. Now, does that mean you're going to be selected? Absolutely not. But it has to be an equal chance. I will use a sample size of 30 from each group, and that is 30 males and 30 females. Why? Okay? Why would you think you need an equal representation from both groups you're measuring from? Right, if you don't, you're going to skew the data, right? 30 females, 1 male. I don't think that's going to work, show you much about the difference between them, right? Okay? So be careful. So answer the following questions using the example above. Does a sample size of 30 mean 30 in both groups or 30 overall? A sample size of 30. What do you think? So it means for each, look at the sentence. I will use a sample size of 30 from each group, that is 30 males and 30 females.
Or each
So that means a sample size comes from each group because your samples need to be about the same, right? So we're talking about how many people in total then? 60. Okay? So sample size has to be the same for both things you're measuring. Do you need an equal number from each group, you think? Absolutely. Now, it's not going to make or break your data if they're not exactly equal. If you have 27 and 29, that's not going to kill you. But as equal as possible. You don't want 1 and 20. Okay? How do we minimize bias? Can you think of some ways you can minimize bias? Okay, so just make sure your sample is as random as possible, right? Okay, so are you going to ask your friends a question about something that you do all the time? No, because they're going to give you the same answer that you're going to give, right? Okay, so there are lots of ways to do bias. All right, let's look at the next part. Describing and comparing sample distributions. So you're just going to see that one of the things that you're going to have to do is you're going to have to describe the data. And one of the main things about describing the data is describing what's happening in the center of the data, the middle of the data. And we have a couple of words that we use for the middle of the data, and hopefully you're familiar with them. What are the two main words that we use to describe the middle of the data? Median and, well, there's actually three. Mode is one, but it's not very helpful, right? Average, which is also called the mean, right? They're the three M's, right? Mean, median, and mode. Mode is a little unusual to use for this kind of data, but you usually use a median or a mean. Okay, good. All right, so if you look at some of these graphs, look at the descriptions of the shapes that you see on page 35. The one at the top is called the normal distribution. If you notice that it starts off small, most of the stuff is in the middle, and then it falls back off. It's pretty symmetrical. It doesn't have to be as perfectly symmetrical as the one they've given, but that's normally distributed. Look at the bottom, look at the next one there. That's a right skew. It's skewed to the right because there's a little tiny bit of data way off to the right. Okay? Be careful with that one. Most people think it's skewed to the right because most of the stuff is on the right, but it's not. It's skewed to the right because there's a little bit of data, a tiny bit, that pulls the numbers off, okay, as you go to the right. Left skew means exactly the same thing. There's a tiny little bit of data skewed off to the left. Bimodal means that you don't have just one place where a lot of stuff occurs. You have two. Bimodal, right? Uniform looks like a box. There's just almost straight across. Now, if you're looking at that, could you really tell where most of the data is? No, it's very difficult if you get that. Triangular is very similar to the normal distribution, but it's tighter. Yeah, it's a little tighter. And then irregular, where you get no real pattern, we don't like that. It's very hard to pull statistical data from something like that. Most things you ask are not going to be irregular. And if you get a very irregular one and you're asking the same question to a population that's kind of similar, then what's probably happened is your sample size isn't big enough. Okay? Most data, strangely enough, is going to fall in some version of that normal curve or be either skewed to the left a bit or skewed to the right a bit, strangely enough. Okay? All right. Look on, so you have some on page 36 where you're just going to say which of these shapes do these distributions tend toward. So we can look at some of that data. What do you think about number one? Think it's a normal curve? You think it's skewed one way or another? Irregular?
Symmetrical.
It looks pretty symmetrical, actually, doesn't it? So that's just a normal distribution. It doesn't have to be perfect, but if you look at it, the spread is very far out. Where's the median? Right in the middle, right? And it's not perfect, but it starts off small at one end, goes up in the middle, and then back down. So that one's symmetrical. How about number 2? Yeah, you could say that it's a little skewed to the left, but that's only one dot. I might be tempted to say that one's triangular because you only have that one dot. But you could definitely make an argument for skewed to the left, but it's really not skewed to the left because it's just one, right? Remember, think about we're really thinking about where most of the data lies. How about number 3? Bimodal. We have 2 distinct high points in that one, don't we? Okay. Number 4. Yeah, I would think that one's irregular. There's a lot of stuff going on there, and the data's everywhere, isn't it? How about number 5? That one's definitely skewed to the right. Okay? There's a lot of data over there on the left, but then it goes way over to the right, and there's enough of it that it will affect the outcome. Right? Good. Okay. So it's unlikely that your shape is going to look exactly like any of those shapes, but you can see from these that you can kind of get an idea. Okay? But an argument can be made for other shapes as well. So be careful. Okay. Now look at the next page on page 37. We're going to talk about comparing shapes. This is critical. This is exactly what you're going to be doing for your inference, right? If you can't read the graphs and look and draw some conclusions from the graphs, you're not going to do well on this. So let's really pay attention and think about what's going on here. So on page 37, so you've got female and male, and what they're measuring is what? Shoulder width. It's down at the bottom. That you always have to have a title, always have to have a label. And they're measuring it in what kind of units? Centimeters. So anybody want to think about what kind of a question they're asking? Now I know you can't give a population because they don't give you a population. But what do you think they're measuring? The median shoulder width, or who has the largest median shoulder width between the males and females, right? Do they give you an age? No, don't give you any information. So we couldn't make a complete question out of this, but we could get pretty close talking about what they're measuring. So, what do you notice about the data for females? Yeah, it's pretty much a normal distribution, isn't it? Start off small, get up right in the middle, it gets bigger, down to the other side. What about the males? Males is pretty irregular. You could argue for bimodal, but I'd say they're pretty much irregular. Okay? All right? So, good. So notice that when for male has an irregular shape, and then the females has pretty much a normal distribution. Good. What does this mean for the sample? As far as the sample, look at the males spread. They're way spread out, and they're everywhere. So that means what? They change more. There's a lot more variation or variability in that data. So it doesn't give you as good, clean information as you could get with the females. Okay? So, and if you look, it says what might it suggest for the population? Well, if you don't have a clear set of data, what do you think you need to do? Make it bigger. Because I guarantee that if you got a big enough sample, it would follow that same normal curve as the females. Okay? Now, not exactly the same curve, but just like the females one did. Okay? Don't let me misspeak. Okay? Let's look at the next page. Comparing the positions and sizes of the spread. What do you think spread means? How far the data spreads out, right? The smallest value all the way to the what? To the maximum. So the minimum all the way to the maximum. You looked at these terms when you were studying those. So what do you see? Notice that the IQR, the interquartile range, right? Okay. Of geography is smaller than the interquartile range of physics. Also notice that the range of scores for geography is larger than the range of physics scores. Okay. and that the middle of 50% of the geography scores lies within the middle of the 50% of physics scores. So all they're doing is just making some generalized things about these. Notice that geography, the spread is much further. So there were some very low grades. So which one had the lowest grades out of both courses? Geography had some lower grades than the physics did, right? And the middle section of the geography, that big blue box, right? That's the middle 50% of the data, fell well within the size of the same area for the test scores from the physics one. Good. What about it suggest for the population? If you get a long line, that means a lot of what? Variability, right? A lot of things happen going on there. If it's tight, what do you think? Hey, all right. Okay. All right. Now, but remember that when you're actually doing your data, you're going to have to make sure that you're very specific with the actual numbers. So getting a general idea is good. That's a starting place. But remember, when you're comparing these two things, you better have the actual data, the number. The median for the girls was, the median for the boys was, right? So make sure that you're very specific about it. Okay? All right. Let's see. Hold on just one moment. That's a good one. We'll talk about how can we create the graphs and the plots that we need in NZ Grapher. Let's just build a little set of notes for that, right? Well, the first thing, of course, is we need a data set. Oh, yep, I did that on purpose, didn't I? Well, let me undo that. So the first thing is we need a data set. And again, you're not going to be asked to create a data set. You're not going to be performing the experiments. You're going to be given a data set to use. Okay? Sorry? Okay? So, right. Once you have that data set, in order to be able to put it into NZ Grapher, what was the first thing you needed to do? Did you just type those all into NZ Grapher? Yeah, you imported the file, but where did you get the file? It magically appeared. No. You did an Excel spreadsheet with the data, right? Making sure that you did the two labels properly, okay? All right. Then you imported that file into NZ Grapher. Right? From there, you then had to select which kind of graph you wanted. Okay? And remember, we want the box plot, box and whisker. Oh, sorry, box and whisker. That's what they call it. Okay. Box and whisker and what? Dot plot. Those are the two things we're going to use to be able to read the information from. And if you'll look on there, there's an option there that gives you the high box plot or some box thing or something like that. Look at it. I can't remember exactly what the thing is, but if you push it, what it does is one of them, just the plain one, will give you your dots, right? Sorry, forgive my terrible drawing. And then it will give you the box and whisker over it. That's a little harder to read. Yeah, if you're comparing them. So what you do is you choose the higher one, and what all that does is it just moves your box plot up above your dot plot. It's exactly the same data. It just moves it up some so that you can have them separated, so you can easily see what's going on. Okay? Right? Also, then, what other pieces of information will you need? The summary statistics from there. And that's just a matter of pushing another button. Right? And it's called summary statistics, isn't it? Summary. Anyway, so you need that. Right? When you're creating this, though, what are they not going to have that you must have? Title. Make sure that you have a title for your data. Now, when you create the Excel spreadsheet, you'll put these on. You'll have names for the two data, so it'll put that on the different axes, right? Right. But you've got to make sure you get the title on there. Don't forget to put a title and any other supporting information that you think needs to be there. Okay. So practice that a little bit, and then y'all will let me know. Did I miss something? Again, remember, I'm not an NZ grapher expert. There you go. Screenshot it, put it on your document. Got to have it. Does this data need to be part of your report?
Yeah.
Absolutely, right? Okay. Including, wait a minute, do you just need the graphs?
You need everything.
You need everything. The list of the data, too. That goes in the appendix. Remember we were looking at that? You're going to have the whole thing, the whole list, right? So you can do the whole list if you want. Stick it on there. Put it in appendix. But, I don't know. Look at the samples. Remember we looked at the sample ones of these that got excellence and achieved? Right? We can look at those some more if you want to, and so you can have an idea. Okay? But remember, you need all of this data to support your conclusions. All right? Does that help? All right. So what I want you to do is just kind of look around at some of the data sets that they have in NZ Grapher. You can also look at some of those spreads from those pages that we just looked at, and that'll kind of fill out the rest of the time since we're not that far from done. Okay?